And moving on, we actually have another developer advocate who's been very active in the comments as well. I would like to invite DeveloperSteve. Am I correct in saying that your legal name is actually DeveloperSteve?
Spoilers for my second slide, but yes,
Oh,
my middle name is legally. Oh, it's fine. No, it doesn't count as part of my time. No, it's fine. No, my middle name is legally DeveloperSteve. I've been doing developer advocacy for so many years now that people just started calling me that. So yeah, when I got married in 2018 and legally changed my name to my married name, which is a combination of me and my wife's last names, then I thought, you know what, I'm going to make my middle name DeveloperSteve. So yes, legally it is DeveloperSteve.
I got to say, I think that's awesome. And just to give a formal introduction, DeveloperSteve is a senior developer advocate at Lumigo. And today he's going to give a talk about deploying and building SDKs as a service. And I'll hand it right over to you, Steve, and you can go right ahead.
Amazing. Thank you. Let me switch to my presentation view. Hello, and thank you all for joining my talk. And wow, what another amazing. I've been to so many of these over the years, and they always just keep getting better. Like everyone just sharing their knowledge and coming together. Also, thank you to the organizers for putting this on, because a lot of work. Everyone in the room applaud. There's a lot of work that goes into these events. So thank you to the organizers. So my talk today is one that's near and dear to my heart because, well, I've lived this, but more spoilers, we'll get into that in a moment. But yeah, hello, my name is DeveloperSteve. Already done the pre-intro, so if you're just joining, yes, my middle name is legally DeveloperSteve because everyone just called me that over the years, and it kind of stuck, although it is my handle everywhere on all the social medias. So if you are watching out there, either live today, please drop your messages in the chat. I totally accept emojis, so please put those as well. Or if you're watching the recording in the future from now, hello from the past, and I hope you are well. But yeah, I am the Lumigo Senior Developer Advocate, which is really cool because I get to play with a bunch of fun tech and geek out with folks all over the world, just like I am now, plus build fun demos and help developers discover observability, monitoring, and well, I just get to geek out with folks, which is kind of fun. And you can tell from the photos that I get to geek out with a lot of interesting folks. One thing, where's my clicker? So I have been in a developer advocate for a number of years now for some really big companies that build, maintain, and utilize like APIs in so many different ways. And so one of the things, there's a number of things that I've kind of noticed over the years. We'll get into that in a sec. But in particular, just having the right developer program around like building out, utilizing, and well, just doing fun things, integrating with your APIs is totally integral. As a developer, and I've been coding since the age of 8, just taking that API and connecting it to all sorts of like different experiences, be it IoT, one of my total favorite topics. They're all my total favorite topics. This is the problem. But yeah, being able to take that API and integrate it really easily and facilitate some type of really nice seamless service is basically only as good as the documentation, the SDKs, and the program that maintains that API, because that is really important too. But that's why you're all here today and why you're watching this video. And so some things that I've noticed, and I think this is kind of going to depend on what the product or service sort of building out from that API, or the API building out from that, you know what I mean, needs to be sort of that amazing service. Actually, someone said at the start of day one, I think a few people were kind of making references to the greatest API in the world is only as good as its documentation or SDKs or, you know, the API construction itself. Like it's only as good as that, which is totally true. I've used some terrible APIs as a developer, and I've used some amazing ones too with horrible documentation that I have to then sort of backwards engineer some stuff to get it to work. Of course, being from the open source world, I always contribute back my findings somewhere so that someone else in the same situation doesn't go through the same pain, and maybe the company running it or maintaining it will be able to use that to get some good feedback. So first and foremost, of course, it needs to be something completely valid, that particular API. Like, it just can't do nothing, because who would use it? No one's going to build anything from an API that uses nothing. It's almost the Seinfeld of APIs. Anyway, needs to be well documented, goes without saying, because like I said, you then having to backwards engineer it if you need to build a particular thing using that particular API, of course. Number of integration options. So this also goes without saying. Also sort of on the back of that too, and I couldn't fit it on that slide too well, but it's also integration options supporting a number of different platforms or languages. And here's where sort of getting some feedback from developer communities or the people consuming your APIs and SDKs, being able to get that feedback back to find out where it is being used and where it makes sense to sort of put more time and effort into building out that integration. Or alternatively, there could be some communities that want to help you build an integration or want to help maintain or contribute to it. Like, there's all sorts of ways that can play out. And I've seen the likes of Stripe over the years. I'm totally going to call them out because their documentation is amazing. But yeah, there's been a number of community efforts over the years where an open source community will come together because they want to use that particular API, and they'll build out and maintain it themselves. There's good and bad points to that as well. I mean, open source, yay. But at the same time, they could potentially be using it in a way that you may not particularly want. But yeah, of course, you can always work with them to sort of, help mitigate that a little bit, and also get their feedback. Again, get that feedback. And of course, the reason why we're here today, SDKs, because I don't want like a developer wanting to consume my amazing API service. I don't want them to reinvent wheels every time they need to do anything with my API, particularly if it's a robust service or product where, you know, they've got all this amazing functionality to use, but again, they have to rebuild the world every time they want to do it, or little the parts that they want to use, and maybe it ends up on, you know, in a GitHub repo somewhere, or it ends up in the hands of the community. And there's a really easy way to sort of build this out a little bit more too, so that you can automate things, which is, again, that's why we're here today. Maintaining a number of SDKs is really, really hard. But I'm sure those of you that have gotten hands-on and done that before kind of know what I'm talking about. So hopefully this will help a little bit, because there's an open source tool that makes this generally relatively easy. There's some caveats to that, and we'll look at that as well. So if you're not familiar with it, this is kind of what I hate to take favorites, but I'm totally going to for this one. And you'll understand why over the next few slides, because I'm going to tell you why. But Open API Generator. Now, this started, and actually where I first started using it was Swagger 2 days. Remember those days? They feel like a long time ago, but they actually weren't. But back in the Swagger 2 days, this actually started as Swagger CodeGen, as an open source project. A really solid group of, or massively solid community, and I can't even shout out them enough because the work they do is phenomenal and powers so many APIs around the world. But Open API Generator is its latest iteration. There's a number of ways to consume it, and I'm going to look at a couple of those first, or I'm going to cover the local CLI version in a moment, which is where I first started using it. Really easy to install. You just npm install a thing, or brew install the Open API Generator npm, and you can generate SDKs straight off the back of an Open API spec, or a Swagger 2 spec. If you're still using Swagger 2, please upgrade to Open API 3 because, well, wait, no, we don't call it that. Open API, that's right. Swagger 3, you can't say that. I didn't say that. But yeah, there is a local CLI version, which is really, really cool. And a good starting point if you are looking to start automating and start generating your own SDKs yourself. There is a deployable service, which is what we're going to look at today, because I wish I'd had this back in the day, but for a telco that I was spent some time with, this was one of the things I was doing, and it literally started with one particular API product, and it quickly led to 40 SDKs because there's a multiple languages per API product, and things escalated very quickly. I should put that as a meme in here, I think, because it did escalate very, very quickly, which is kind of good and bad. But I was only one person and there was a lot of them and there was a lot of changes. So anyway, automate everything. We'll look at that because there's some ways to do that today. Like I said, it does support OpenAPI and Swagger. It actually still supports Swagger 1, I think, if you're using that. I mean, please don't. But if you are, it does support that as well. More importantly, now I've seen this grow a lot over the years, but it does support a lot of languages. I didn't count them all this time around because there's actually more of them since last time I used it, which is amazing. Like, this is literally one of my favorite. This is literally my favorite open source repository. Now, it's important to note like the complexity behind this project, because there's the core team, the core open source team that maintains the core, like the engine, and then there's like little sub branches, not even little, there's sub branches for every one of these, like, as part of the project. Just to give you an idea on the scale, it's phenomenal. And again, if you are using this or looking to use this, please contribute back if you can, because there is like an insane amount of work that goes into this and has been going into this for a number of years. Like, this is built out a lot and continues to build out a lot. So yeah, please contribute back. More importantly, it's important to note, this is the disclaimer. It's important to note that the SDKs that generate from your spec that you throw at it, the generator, I mean, it works. It doesn't do it very nicely because it's a default template. So the good news is that they're moustache templates for the most part, depending on the language. So you can customize like any element of it that you need and have that as part of your deployment, which is amazingly cool. And I've seen Square was, I don't know whether they still are, but they were using this for a little while. And yeah, they actually had their own custom templates, which is great. Particularly like getting that feedback back from the communities using your SDKs and your API, like particularly as you redesign some things and to, well, refine it, make it better. Based on that feedback, you can funnel that back in and like make everything else refine and build out with it. So it's important to note too with a lot of these, and again, it depends on which languages, but you'll also get README documentation as part of the output, which is pretty cool. Again, it needs work. So start with default and work up. I think I've covered that one. Yeah, it is a really huge community. Please contribute back because they do amazing work. I think they're always looking for sponsors too. So if you are so inclined, contribute back to this project, because I'm going to say all the nice things about it. No, because it's a good project. So the generator itself, how it works, is relatively simple. Don't let the right-hand side of this screen fool you, because it is relatively simple. They're just all the options, which again have actually changed since last time I looked at them, which is great to see, but I actually haven't had time to play with all these. Some of these are language specific as well, and there's actually ways to generate or get a list of help options for a particular language or platform as well. But essentially, you do something like that at the command line and like specify the -G language or module that you're looking for. Include your YAML or JSON, and it gives you back an SDK. Well, providing it recognizes the parameters you throw at it, you essentially get one back. Now, and this is where I first started using it, because I was doing like a single command line, threw my spec at it, and an SDK came back. I ran some tests on it because a few times I may have deployed before running tests, and some users came back and told me that they had some issues, so had to redo things and retest them again, which is why testing is always important. But also, actually, the other side of that sort of mini story too is that it was interesting because we didn't know whether anyone was using them. And then when I broke them accidentally one time through not testing them, please test them, we got some user feedback and we knew people were using them, which is always great. What I ended up doing, though, to try and automate things a little bit, and again, like I started sort of maintaining 5 and ended up with 40 very, very quickly, which is a lot of work for one person. But yeah, I actually wrote some bash scripts on my local, which wasn't ideal, but yeah, it was the quickest option at the time, where I would actually have specs, sort of configuration for different language types that we were supporting. And if that file existed in a different directory, then my bash script would basically do the generate and dump out the latest version, and then I could run some tests on it. Handy hint, probably pick some of the more common languages you're looking to support to start with. I'm talking like Node.js, of course, everyone's noding these days, and Python. Python's probably the most integral because it's going to be the one that probably will break depending on what it finds, what's in your spec, and then when you generate things out. So Python was always the one I would start with first, and if that worked, then output all the things, literally output all the things. Oh, and those are the configuration files. I mean, it was quick and nasty, but hey, it worked. So you can actually run this as a service. I've been playing around with this lately just for fun, really. But there isn't a whole lot of there's a little bit of documentation on this in the website. Essentially, I'm running it inside well, it's containerized inside. I'm running it inside ECS, but we'll get to that. So essentially, what I've been playing with is I'm using AWS API Gateway. It's a really basic API just to have something to play with, essentially. I've got a Lambda function running behind that particular API route, and it's connected to a database, which is pretty simple. For the SDK generator, I'm running that inside AWS ECS. And of course, I've got a containerized version of OpenAPI generator running. And that's kind of it. There's just one more step. But essentially what happens is you can generate out an API spec from the API gateway, like really, really easy. In an automated way too. Like you can have it go out as soon as a new version's out, just dump it into like an S3 or somewhere sort of that you can store it. And as soon as that particular file exists, then you can pick that up and throw it at your containerized OpenAPI generator, which is pretty cool because you can also run through a list of different languages you want to support. And off the back of that, you then get an SDK out. Now, the most important part of this entire process, I mean, that's all kind of important, but like I was saying, you need to test it. So you can automatically deploy that to a Lambda function and essentially drink your own Kool-Aid because you need to do that, because otherwise you'll break things and then you'll get a whole bunch of users emailing you. You don't want that because users, they get upset, or developer users will get upset. Oh no, they're users for their services too. Anyway, test everything. And then when you've tested it, test it again just to make sure. This is where I would switch to my this is fine C, but I'm not going to because I haven't got much time. But here's where things get interesting, because one of the things as a developer I always know is when you're building out an SDK, it's important to make sure that you do some testing on the actual resources that particular SDK uses. Because nobody likes an SDK that uses up, well, all the resources and costs everyone all the money. No one likes that. Or throws a whole bunch of errors just because that particular route functionality inside that language SDK works really well. Yeah, it doesn't mean that things aren't really going on like really badly behind the scenes. So like tracing, this is where tracing can help, because you can detect a lot of this sort of stuff. And before the users even are able to give that feedback or find this for themselves, you can have some changes put in place, either with the API routing or even with the moustache templates for the SDKs themselves, so that things run really, really well, because that's really important. Again, like once you've got those users, sort of developer users, building out an amazing experience, you want to make sure you keep them and sort of keep them happy and make sure their apps are behaving really nicely with your SDKs. So distributed trace all the things. We're going to look at how that can help in a moment. So those that aren't familiar with it, essentially cloud native applications, as we know, scale out super, super quickly and enable all sorts of different API routes and all sorts of amazing things that happen behind the scenes. But they can, again, scale out super, super quickly, particularly when you're dealing across multi-regions and a number of different services and a number of different versions of a number of different services. You get the picture. Things can get a little bit messy. So this is where distributed tracing helps. And I've actually seen some really cool talks talking about that and OTel over the past few days as well. But tracing helps organize all that and keep an eye on things. It helps you find errors and find issues inside your infrastructure and stack, and keeps things nice and organized. The best part is it's agentless. Well, that's the way we do things at Lumigo anyway. So it means you don't have to install anything. You don't have to run anything. You literally just have to connect things up and that literally takes a couple of seconds. And you can trace and find all these different things, which we're going to look at in a minute with our SDK services. So if we look at API gateway monitoring, for example, you're able to detect all sorts of things from memory usage to, see, look at that, no errors. Isn't that great? It's a pretty simple API, just in secret. If you want to see it, hit me up after this and I can show you, or in the future, if you're watching the recording. And I can give you a demo or put the repo as well. But it helps you keep an eye on all your infrastructure, which is amazing, and the things running inside the infrastructure, and lets you trace any potential errors and pitfalls that comes up. Actually, it also sends you an alert as well. So that Lambda function I was talking about that's sitting behind the API gateway, for example, you can see here all the invocations during my rigorous testing. Just test everything and then test it again. You can see the invocations here, and in particular, that bottom one, even the API routes, that's going to cost you money and also delay users' response. Oops, I hit the wrong button. I should have tested that button. The API response time is going to affect your users essentially inside their application or consuming your service. On the other side of that, if it's using too much memory, or too much resources, and also throwing a lot of errors, that is also going to cost you money. Even at fractions of a cents, those fractions add up when you're talking scale. Cold starts in particular, which is what this one is. Yes, my API service is called DevJokes. I can give you the dev joke at the end. Anyway, the DevJokes Lambda service in this case is you can see the cold start time, and that's the time it takes for the initial spin up of the actual function to, start. Beyond that, though, relatively quick. Actually, that is pretty quick. I would be happy with that, but it's not doing a whole lot other than connecting to a database. These things get rather complex, though, as functionality builds out and as your users start telling you they want different bits of functionality to be added or things changed, etc. Anyway, the other part of our demo or our example here was the actual SDK generator. So SDK gen as a service, or I haven't actually worked out how to pronounce this yet, but SDKs sounds like something from IKEA. But anyway, it's not. Not yet. Anyway, this was running on AWS ECS, and we containerized the actual open API generator, which was pushing out SDKs into our nominated location, which in this case was an S3. But that is also something that we can sort of keep an eye on, how much resources it is using. And the best part is because you can build this into your build pipeline, you're able to monitor, again, how much resource is being consumed with that service being available and running. Maybe you only need to use have it with a certain percentage of resource at a particular time of week. Maybe it just gets spun up as part of the deployment process. Maybe you stagger the API release or the SDK releases based on API versions or changes in its functions. This is all the stuff you're able to look at once you've got that distributed tracing in place. And you can go down to the different tasks themselves that are running on as part of that particular cluster. And then again, sort of question whether you need as many resources running, if there's errors being thrown. Sometimes if there's services running that you weren't even aware were running, you're able to spot those and set up all types of alarms and whatever else that you need to be able to, keep the engine running happily. Of course, the last part of this, and I want to say the best part, but it's all kind of fun, is the actual SDK testing itself, because again, you want to make sure that the SDKs being generated kind of do everything you hope they would do and a little bit more. This kind of gets a bit meta though, because we're about to go full circle. I couldn't find a better meme. They insert meme here, but this is where it goes full circle, because this SDK that we're about to trace monitor is also connecting to the API gateway that already, yeah, I'm already getting lost in my own circle. Anyway, we're monitoring everything. Monitor all the things. Yeah, this is actually connecting back to the API gateway, which we're monitoring as well, but we can deploy these SDKs to our own Lambdas and be able to write some scripts where we can check to make sure that everything inside it is running as we would have wanted it to. So you can see here, like, this is a before we start looking at refining either the API routes. This is where some investigation and some tracing needs to come into play, because you can dig into the API route itself to be able to see whether it's a Lambda issue, like a response time issue with the actual API. Maybe it's doing too many functions. Maybe the cold starts are the issue and you need to keep some or set up some concurrency. It's a whole other thing. But yeah, this is where we can do that, use distributed tracing to start to investigate how we can make our SDKs better or response time better. Now, I do know one thing I need to mention is these particular calls were just running on default Lambda deployments. So these weren't refined in any way. These were literally just as is. But again, we're just trying to set the baseline for how we can improve them, essentially. And you can, like, this is the after, and you can see the response times starting to get a little bit better. I'll take the 76 milliseconds, but that 951, ouch. Yeah, that needs some concurrency. But this is where you can start to investigate, like, how you can make things better, like what is slowing it down, what is the problem. This is my Steve Jobs moment, just one more thing. One thing I want to mention here is as part of the trace, we're actually able to, particularly with Lambda, and this is only got released about a week ago, which is kind of cool. But we can also map in SNS and SQS as part of a Lambda flow to be able to, well, see the whole view. You can literally trace everything. It's so cool. You can literally trace an entire transaction from where to go through your stack in, well, in all one view. As you can see there, you just click through and see all the variables being passed through. Of course, any critical stuff is hidden, which, oh, you can kind of see on there. It's got route key hidden information, which is also really cool because we like to keep secrets. Well, we need to. That's really important. Just wrapping up because I am not far out before we're going to run out of time, and it's the end of the conference. Yay! Now we get to go party, right? No. Yeah, you do. Anyway, just some takeaways before we go is please always design APIs for dev consumption. Get their feedback. That is always so important. Like, understand how things are being used, why they're being used the way they are, and how you can make things better. There's always that next level. You always got to be going for that next level. And ultimately, yeah, rinse, repeat, and refine, because yeah, you need to do that. No, it's always, again, that's how you make things better. And of course, monitor and trace everything, APIs and SDKs, deployed code, and all the things to make things hum really well and allow your users to have a really good experience consuming your API and your service. Just some final things. We run free office hours with some of our serverless heroes. So if you are using serverless, want to use serverless, or just want to geek out, please hit us up. The link's on the screen, but hit me up on socials and I can send you the link as well. I'm DeveloperSteve everywhere, actually everywhere, most places, except Twitch, but that's a whole other story. Also, if you're looking to find out more about how distributed tracing can help, then please check out our blog as well. There's some great articles, write-ups on why you need to do it, why it's important, and why you need to do it. And just lastly, always love ending my presentations with this, is please always use your tech superpowers for good. Please contribute back to Open API Generator, of course, if you can. Even just helping with their reading. And always be excellent to each other. Thank you very much.
Thank you very much, Developer Steve. I would love to ask you some more questions, but unfortunately we are out of time, and I need everyone to go back to stage one for some final remarks. But again, a very entertaining presentation, and I hope wish everyone will check out your Twitch streams and find you on your socials. Thank you again for coming. Thank you for your talk, and feel free to check out the final remarks on stage one.
Amazing. Thank you.